and welcome to virtual PDE office hours. If you have any questions, just type in a comment below and I'll be happy to answer you. So let me just try it out to see if it works. Hello, Paya. Woo. Excellent. So yeah, just ask away. So and by the way, I did this from a Math 3A class and it worked really well. So if it works well here, I might do it a regular thing because it was really great. And also, I apologize if you can't hear me. It's just the acoustics of this room. And but if you want me to speak louder, I'd be happy to. So I know there's one person watching right now, and I know it's me on my laptop. So hello, Paya. And if I'm ever looking like this, it's because I'm looking at the comments on my laptop. So I'm recording with my phone, but looking also at my laptop at the same time. Ooh, hello, Kimberly! What a nice reunion! Hi, thanks for checking in. I can't hear you, but I hope you can hear me. But I can still see your comments. Yeah. Oh yeah, Zoom might also be a good idea. Yeah, that's true. Sure, I'd be happy to go over problems. That's what I'm here for. Yes. Chapter 1.2. Okay, 8 and 9. Let's see. Oh yeah. Okay. So for 8, you have to solve AUX plus BUY plus CU equals 0. And the problem is, so far we can only solve stuff like AUX plus BUY equals 0. Yeah, I mean, if you want to talk to me, come to my actual office hours in person. But yeah. But I can still read what you're saying. So anyway, what we want to do, we kind of want to change this PDE into one that we already know. And I believe, and correct me if I'm wrong, you have to use the following. V equals E of e to the minus, let's see, I think AX over C. I don't quite remember what the hint says, but Anyway, so this you're not responsible to know for the exam. I would tell you use v equals to u e to the minus ax over c. Then what we get is u is e to the ax over c. And then, sorry, times v. And then you just calculate a bunch of partial derivatives. Oh, cx over a, okay. Okay, good. So it would be here minus cx over a. Okay. And this is sort of like an integrating factor in PDEs. So, so then what we get is u is e to the minus cx over a times v. And then let's just calculate a bunch of partial derivatives. So ux, it's minus c over a, e of minus cx over a v, and then using the product rule, or the product rule as I like to call it, and then plus e of minus cx over a vx. That's one thing. And then for uy, notice this does not depend on y, so it's just a constant. And then we get basically uy, it's e of minus cx over a vy. And all we want to do is plug this into the PDE, and then what we get, let's see, so AUX becomes A times minus C over A, E of minus CX over A, V, and then plus E of minus CX over A, Vx, plus B, E of minus Cx over A, Vy, and finally Cu, which becomes C, E of minus Cx over A, V. And that's equal to 0. Now, it looks absolutely horrible, but there's a beautiful simplification. Unless my hint is wrong, which might be, but it looks like it's okay. So minus C E of minus Cx over A V plus A E of minus Cx over A Vx plus B E of minus Cx over A Vy plus C E of minus Cx over A V equals 0. And lo and behold, look how beautiful this is. This term cancels out with this term, and we left with E of A E of minus Cx over A Vx plus B E of minus Cx over A Vy equals 0. And not only that, we have this common factor, which we can just cancel out, and we're left with, how beautiful is that, AVX plus B Vy equals 0. So, V of xy, it's any f of I LMAO, AY minus BX. But what was V? I believe V was E of CX over A. So, E of Cx over A U, I think. So then U is E of minus that equals F of AY minus BX. And we're left with V being E of minus Cx over A, F of AY minus BX. Let's see, unless, let's see, so U is E of minus Cx over A, so, U is that. I don't know what I'm talking about, sorry. So V is, oh God, I keep forgetting. So V is E of Cx over A. U, so U, no. V is E of Cx over A U, so U is E of minus Cx over A V, so really E of E of Cx over A U equals to that, so U indeed is equal to this. and you have the solution of your PDE. I don't think that's good, huh? Nice. So does that make sense? It's not magic. It's PDEs. Yeah, you know, but and what else do I want to say? Yeah, I mean, but that, you know, I have to understand, this is very typical for PDEs. Namely, kind of play around with your functions or your variables to simplify your PDE. And you have seen that today in lecture with this coordinate change that really simplified our equation a lot. Yes, absolutely, 9 is not a problem. So, for 9, also actually not that bad. So let's solve ux plus uy. And luckily there's not much to do. So notice this is an inhomogeneous equation and inhomogeneous linear equation. So of the form, let's say LU equals F. And if you remember from lecture, the general solution of LU equals F is equal to the homogeneous solution plus a particular solution, which you might also remember from 121a. So all we need to do is solve LU equals 0 and find just one solution of LU equals F and just add them together. So to solve LU equals 0, that's ux plus uy equals 0, just like a transport equation from the beginning, and you get u of xy. So the homogeneous solution is f of, again, ay minus bx, so y minus x. That's one thing, and I think you can really check that this is true. And, well, to find a particular solution, here you just have to guess. So can you think of one function, very easy function, such that if you differentiate it with respect to x, and you differentiate with respect to y, you get 1. Well, just, again, guess. For example, x would work, or y would work. So a particular solution would be, let's say, x. And obviously, for more complicated equations, it would be more complicated, but if I ask you a question like that, it would be one of the easiest guess possible. And then, what is your solution? Well, it's just the sum of those two. So f of y minus x plus x, or plus y, it doesn't matter. So let's see. Yeah, that is the beautiful thing. If you have just one solution if you just have one particular solution, if you add it to the homogeneous equation, it gives you all solutions of the equation. Just like you did, again, linear algebra in 121a or in 3a, to solve ax equals b, you just find the general solution of ax equals 0, and you just add one particular solution of ax equals b. And the magic is that gives you really all solutions. It makes sense. What I really want to emphasize, it's just a miracle of linear equations. It's very, very wrong for nonlinear equations, and that's why my life is so miserable. Perfect. I'm glad. Again, I think really most of the problems are okay. I just think really it's just 1.2 is a bit tricky, but it seems you got it. Okay, you're welcome, you're welcome. I'm glad I could help. No problem, no problem. Thank you. You too. Good night. Good night. Sleep well. Hello. Okay, good question. So nonlinear equations, are we gonna do this in this course? Unfortunately, no. So in this course, we'll just talk about linear equations. That said, so even in, I think, 112b, you won't do linear equations. Maybe in in 112c, you might tackle a couple of nonlinear equations. That's usually around the last part of the book. Yeah. But that said, we will see some techniques that might be useful for nonlinear equations. Like when we do the wave equation, we do energy methods or maximum principle methods for the heat equation, and those will also apply for nonlinear equations. So not all is lost, but also if you want to see nonlinear equation, it's very useful to take some analysis, because it's really analysis, or more specifically measure theory, that helps us deal with those equations. Nonlinear PDEs are really cool. Like, if you want to talk about this in person, I'll be happy to give you a little taste of it as well. Thank you so much. No problem. I understand. It's I mean, honestly, I just wanted to try it out to see how it's going. It seems to be going pretty well, so I mean, I might do this more often if people are interested. Especially, I'm sure, like around midterm and like, final exam time, there'll be lots of questions. So. But I'm really glad we survived 1.2, because I thought it was like one of the trickiest sections. And after that, actually the course might get maybe even easier. We'll see. I agree. That's one of the reasons I'm doing this, because it's sort of office hours from your phone or something. I think it's a cool idea. A friend of mine suggested that to me. He tried it for his 2B class, and he said it worked really well. So I think, I mean, how cool is modern technology, right? It's And not only that, you will be able to see the transcript of this, afterwards. So even if people miss the office hours, or even if you're not my student, you will be able to watch this and just catch up on interesting stuff that we talked about. Excellent. Yes, yes, yes. So if more people, I might ask the class, but if more people are interested, because since no one, for example, showed up to the office hour in the morning, I could maybe just replace it with virtual office hours at night. Probably won't be 45 minutes long, maybe half an hour long, but still, I think it's a great idea. Honestly, I'm pretty impressed, I think, because I had no idea how it was going to work, but now it seems to work well. Yes. Okay, good question. So you were still talking about this equation. So it's very important when you talk about the particular solution, you need to have a particular solution of the inhomogeneous equation. So when you say that ux plus uy is still 0, well, that's not quite true. Because if you differentiate x with respect to x, you get 1. So if you do upx plus upy, you get derivative of x with respect to 1, which is 1, derivative of x with respect to y, which is 0, and indeed you still get 1. And also it's true for y. So if up is y, because then upx would be 0, upy would be 1, and you would still get 1. And by the way, you might ask, so how can we reconcile this? Because here we have an x, here we have a y, but notice if you have f of y minus x plus x minus y plus y, well, this whole shebang, let's say minus y minus x plus y, well, this whole shebang is still a function of y minus x. So you would still have, let's say, g of y minus x plus y. So there are really two different ways of writing the solution. So again, that was just a practice with, just particular and homogeneous solution. Obviously, in practice, if I put a crazier function here, it would be much, much harder to solve, and it's kind of beyond the scope of the course. If you take a graduate PDE course, by the way, you will find a super rigorous and systematic way of doing this. Here I was just hand-wavy with like vectors and curves, but in general, there is a set way of doing it. You're welcome. So I don't know about the Zoom thing. Let's see. It seems a bit out of focus. But hopefully you can still see the whiteboard, I hope. Okay, good. I'm glad it's readable. I don't know, it's kind of weird because when I do YouTube videos, I can focus it. But here it's like, yeah, this is, I think, the best I can do, unfortunately, at least with this lighting. Yeah. No problem, no problem. Thank you for dropping by. I really appreciate it. I really wanted to see how it works, and obviously later you might have more questions. And yeah, see you on Friday. On Friday I'll do more, I cover the transport equation, which is very similar to this, and then I'll just talk about more generalities about PDEs, like boundary condition, and like more kind of types of PDEs. We'll see, there's some interesting features. Awesome. Yeah, see you Friday. I'm still here. I'm just sitting down. I've been standing for like 3 hours, so if you have a question, just. My hair confirms my presence. Oh yes, excellent. Yes. Okay, no problem. So that's a great question. Unfortunately, I ran a bit out of time before, but it's simply just like at the beginning. Let's say, forget about x prime and y prime for now. If I say ux equals 0, then what this means is that u doesn't depend on x at all. So u is a function purely of y. Ux equals 0 gives you u equals f of y. And here we have the axes x and y. Well, it's exactly the same for the other one. So if we have our axes, let's say x prime, y prime, well, eventually we found ux prime equals 0, which means u doesn't depend on the x prime variable at all, so it has to depend on the other variable y prime. So in other words, in that case, u is f of y prime. And that's why it's y prime, because it's just the other variable. You see, it's not x prime, it's the other one. Just like in the other one, it's not x, but it's y. Does that make sense? Excellent. Again, I'm still here. I'm just sitting down. So if you have any other questions, let me know. Maybe let me try playing with this a bit. Oh, hello. Yeah, that's my office. Let's see. Yeah, that's my office. I just did nothing, didn't I? Okay, sorry. Okay, sorry. Oh yeah, now I remember. I was like, why am I not just doing it like that? And I remember. Wait, is that? Oh, it does show it in reverse. Okay, because on my phone it just shows it in like reverse mode, but. But it seems okay. Weird. Okay, okay. It seems that the camera is adjusting. Oh, that's even better. Then I don't have to look at comments with my phone. I can just watch them like this. So weird. Also, so 10 more minutes left, then we'll call it a day. But yeah. So if you still have questions, let me know. I'm still here, so just. I should rename this channel Dr. Payam's hair because that's all I can see now. Oh. Or Dr. Payam's baldness. You know? Sorry, it's 7:40 in the evening. That's what happens after dark. Oh, I also need to go to Trader Joe's. I forgot. That's also important. Well, it's okay. It's open till 9. So. Oh, yes. Oh, no, so the values of -5, 3, and 1, they're completely arbitrary. All I'm saying is, let's say we have curves where u is constant, like this. Okay. Then, all I'm saying is, well, u has to be constant here, so it has to have a certain value. I don't know what that value is, but just for illustrative purposes, I bet 5 or -1 or 3. And you see, this is why I also said, well, it's really f of that weird variable, because what this means is that on this curve, to have a certain constant, on this curve have a certain constant. So you see, if question mark here is 2 is this curve, then what we have, f of 2, so f of this curve is 5. Or like if question mark here, I don't know, it's 0.5, then f of 0.5 equals -1. And depending on which values of f you choose, it gives you the corresponding values of u. Is that what you meant? Ah, perfect, perfect. Yeah, it makes sense. Well, I think it's very nice. This is a very unique feature of functions that maybe you haven't seen in Math 2D or anything, and it's a very unique feature of PDEs. at least of first order linear PDEs, because man, in a second order all hell like breaks loose. Yes, yes, yes. So f of 2 could be any other number. You see, f is arbitrary. But once you fix your function, then the values are determined. Let's say, for instance, f is a squaring function. So f of x, or I guess, or f of question mark equals question mark squared. Then, f of 2 would be 4, which tells us on this curve, u would be 4. Or f of 0.5 is negative, is 0.25, then u would be 0.25. Yes, and that's true. It's because f is arbitrary. Awesome, thank you. And yeah, I think last minute, so if you have any other questions, just let me know. Perfect. I'm glad I answered all your questions. Yeah, see you Friday for transport equation extravaganza. What else do you want to say? Yeah, I mean, it sounds like a fun format, so I might do this again. Maybe just half an hour or something, because has been dragging for a while, but I still think it's a cool idea, pretty convenient. So. All right, so I think that's it for today, and see you Friday. And in case you're watching and you're not in my class, what are you doing here? But please make sure to subscribe to my channel. Thank you so much. Bye.